Welcome back to another video on digital design. One of the things we run into is once we have built a circuit, how do we test the circuit? How do we create inputs for ones and zeros to come in? And how do we know the result is 1 or 0? And that's where we're going to talk about, that's a topic we're going to talk about today in this video. Is what we're going to do is we're going to use switches to create input that is 1 and 0 based on the switch setting. So switches are simply, I mean, you can, if you don't have a switch, you can use a couple of pieces of wire. When you connect them, you can assume the switch is closed. When you open it up, the switch is open. So we understand. So when the switch is closed, we can say it's a short. Electricity can flow. So when the switch is closed, it looks like this. And the way these switches work, the on is closed. So this, you can think of it as being closed. And when it's just, so when you move the switch over to that position, it will be closed. And here it's open. Okay. So when it's closed, R is equal to 0. And when it's open, like here, R is equal to infinite. So it's open. Okay. So when it's short, that means electricity can flow. When it's open, electricity doesn't flow. Pretty straightforward. Since we're doing digital design, we may need many inputs. They have these switches that come in packs of 4, packs of 8, or even more. But for what we are doing here, I'm just use an example of packs of 4. So there's 4 independent switches in here, and so we can use that. Another question is, how do I use this to create an input of 1 and 0? The only appropriate way to do it is this way, where you connect your resistor to a 5K, and then you connect the switch to this 1K resistor, and then this would be your input. So for example, if you have a gate, let's say you have you have a gate and you want to make this a 0 or 1. It comes out of here, and you can, let's say that you have a NOT gate, and that's what you do. So when your switch is open, this is directly connected to 5 volt, and since this takes a very small amount of current, like a 1 microamp, the voltage drop across 1K is negligible. So that means this will see almost 5 volts, which means it's going to see it as a 1. Okay, when the switch is closed, then what it's going to see is it's going to be connected to ground, right? So the current will come through here. All the voltage drops, 5 volts will drop out of here. So in this case, you will see a 0 volt or 0, which goes through that. So by opening and closing the switch, you're simulating a logic 1 and a logic 0. Great way when you build your circuit to test your circuit, what's coming in or not coming in. Okay. So that's how you create inputs. Now, how do I know whether my value is high or low? We use something called an LED. LEDs usually are somehow they indicate which leg is positive, which leg is negative. In Tinkercad, one of the simulation tools we use for this class, or if you're in a physical world, one leg is longer than the other leg, and that's how you know which is positive, which is negative. But for what we are doing, let's assume there's a bend, there's a slight bend to one leg, that's the positive side. And how, when you map it into the logical realm, this is what a diode does is, as you move current in this direction, current can only move in this direction. Current cannot move in this direction. That's a backward, and basically it's a one-way valve. You can only go one way. And when you move a current through here, depending on how much current, the more current you put into it, more light will come out of it. Okay. So and then of course, if you put too much, it'll burn. Okay. So what this does is we put electricity here. If let's say if you have a logic 1, which means logic 1 means this is 5 volts, electricity flow through here, and then it lights up. The only thing we got to be a little careful is that we need to make sure that we do have something to limit the amount of current, because if 1 is 5 volts, if it's 1 is 5 volts from the device coming in, and we don't have a resistor to limit the amount of current that goes through here, then what's going to happen is that you're going to burn your diode. So a 1K resistor, you can, if you want it really bright, you can make it 300 ohms, but I would not recommend going anywhere below 300 ohms. 1K is the norm. It's pretty lit up, and it's not too bright, but it's pretty lit up, and it's safe, and your LEDs will last for a long time if you do that. So this is the only configuration that's a valid configuration for powering an LED and turning it on. Okay, so now the question becomes how would I connect, let's say, an AND gate to it? As you can see, the switch is connected. It's drawn a little bit differently. If you remember, it's just bent, but still, you've got VCC going through a resistor. This is really important, and that's where the input comes out, and then the switch to ground is connected. By the way, sometimes the ground may be shown as an arrow pointing down, sometimes with the ground showing just the word ground. So they're about the same. And VCC is also just to re-emphasize, it's just 5 volts for us. Okay, that's just a nomenclature people have used to use to refer to the bias voltage, which for us is 5 volts. Okay, and that's pretty much all there is to it as far as switches and LEDs is concerned. And just make sure, I think the biggest thing is to remember which side is the positive, which side is the negative, and the current can only flow this way, and making sure that you have a resistor here so you don't burn your device. Okay, so that's it. So that's basically it. There's a homework assignment for you to connect LEDs to some switches to LEDs and make them turn on and turn off, and so that basically would be just making sure that you do the right configuration for it to work. So, for example, if I were to take a LED, take a switch. So I have a resistor, my 1K resistor, then I have my switch, and then I have the ground, and here is when the input comes in. I can directly connect it to an LED and to a ground. And when the switch is open, it'll turn on. When the switch is closed, it'll turn off. And that's pretty much it, because this side voltage has to be higher than this side for it to light up. So for the homework, you can kind of basically do that. Okay. So that's that. So the key here was, how do you connect the LEDs? We talked about it, and how you connect the switches. Those are the two things. Wanted to make sure we got a good handle on it before moving forward. And it's tempting, if you're not paying attention, it's very tempting to hook up these all different ways that are not necessarily correct. So you want to make sure you look at this and remember that the LED has to go through a resistor to ground to be correct, and a switch has one side of the resistor has to go VCC, the other side connects to the switch and is the output, and the other side of the switch has to go to ground, which is voltage equal to 0. All right, that brings us to the end of this quick video of how you can generate logic 1, logic 0, and how you can show yourself that you got logic 1 and 0 through LEDs. Thanks for watching.